write these parametric equations in rectangular form, notice we've got some trig involved. So we're trying to eliminate that parameter again. So here's what we're going to do. We are going to need to use our trig identities. Okay, sine squared of t plus cosine squared of t equals 1. Okay, we're going to have to use that somewhere along the line. So here's what we're going to do. With these two functions, I'm going to divide by 5 to get the trig function by itself. Okay, I'm going to divide both of these by 5 to get the trig function by themselves. Okay. Then, since I'm going to have to use that trig identity, I don't have my trig functions squared right now. Well, I can fix that. I can square this entire equation. I can square both of those equations. We can do it as long as we do the same thing to the left side as the right side. You're allowed to do that. Okay, so when we square those, this is going to turn into x squared over 25 is equal to sine squared of t. And this one is going to turn into y squared over 25 is equal to cosine squared of t. All right, so now we finally got our trig equation squared. In order to use our trig identity that sine squared plus cosine squared equals 1, we need to add these two equations together. So we're going to add what we've got on the left side. We've got x squared over 25 plus y squared over 25 is equal to, add what we've got on the right side, sine squared of t plus cosine squared of t. It's kind of a systems of equation kind of thing. It's been a long time since y'all have done systems of equations. But you can add any two equations together that you want to. You just add the left sides and add the right sides. Okay, so now finally, we've got sine squared of t plus cosine squared of t. That is always, always, always equal to 1. Doesn't matter whether we're dealing with parametric equations, whether we're dealing with trig identities, whether we're dealing with, what else do we do with it? With vectors. Okay, if you see sine squared plus cosine squared, it always equals 1, as long as they have the same variable inside the function. On the left side, they have the same denominator. So how about we make that a single fraction? X squared plus y squared over 25. And then just to clean it up, we can multiply both sides by the 25. So we get x squared plus y squared is equal to 25. X squared plus y squared is equal to 25. So what have we written the equation of? What is that the equation of? X squared plus y squared equals 25.
So would it be like 5?
What? X squared plus y squared is a circle. That's a circle at the origin with a radius of 5. Okay, that's a circle at the origin with a radius of 5. So those are apparently a possibility for the parametric equations of a circle. Let me show you how you can graph in parametric mode. There is parametric mode on your calculator. If you go to mode and down where we changed it to polar the other day, parametric is the second option beside function. And then when you go to your y equals, look at what we've got. We have x sub 1 of t, y sub 1 of t, x sub 2, y sub 2. It's giving you the place to put in the x part, 5 sine of, and notice when you hit your x button, now it's t's instead of x's. Just like when it was polar, it put thetas instead of x's. Okay, and then put in your y equals 5 cosine of t and hit graph. And once again, my window is not square, so it doesn't look like a circle. So I square it up. There's our circle. Okay, so that's just something you can use to kind of check yourself. You can check yourself, excuse me, to compare the parametric form to the rectangular form. If you can recognize that x squared plus y squared equals 25 is the equation of a circle with a center at 0, 0, and a radius of 5, then you can compare that. Or let's think about this in a multiple choice context. If they give you these parametric equations and they say write it in rectangular form, well, how about we graph the parametric equations, look at the graph, and see if we can match up any of the equations with that type of graph. That kind of makes sense? If you can graph that, you should be thinking, oh, well, I'm looking for the equation of a circle, and it's centered at the origin and has a radius of 5. Which equation is that? Okay, let's look at one with secant of t and tangent of t. So if we're thinking along the same lines as what we just did, we used the trig identity, sine squared plus cosine squared equals 1. So what was the one with secant and tangent? Anybody remember? Tangent squared of t plus 1 is equal to secant squared of t. So if we're going to use it in the same context that we just used the other one, we need secant and tangent on the same side. So we need to subtract tangent. So 1 is equal to secant squared of t minus tangent squared of t. Okay, so let's kind of repeat the process of what we did a minute ago. X, the secant is already isolated. We don't have to divide anything there. For the y, we do need to divide. So we have x is equal to the secant of t. We have y over 4 is equal to the tangent of t. We do the same thing we just did a minute ago. We need those trig functions to be squared. So square both of these equations. We get x squared is equal to secant squared t. And we get y squared over 16 is equal to tangent squared of t. We don't need to add this time. We need to subtract these equations, okay? Because we need secant squared minus tangent squared to get this equal to 1. So we've got x squared minus y squared over 16 is equal to secant squared of t minus tangent squared of t. Secant squared minus tangent squared is 1. And we don't want that denominator of 16, so we go through and multiply each term by 16. So we get 16x squared minus y squared is equal to, well, actually, sorry, we don't want to do that because it's equal to 1. It's a minus. So which conic section are we talking about? Sorry, go back a couple of steps here. A hyperbola. Okay, it's a hyperbola. Hyperbola was the only one with the minus. Okay, and the hyperbola was always equal to 1. That's why I went back and erased the multiplying by 16. Okay, a hyperbola is equal to 1. This does have a center still at the origin because we're not subtracting or adding anything with our x's and our y's. Which axis is it going to cross? Which axis is it going to cross? The x. Okay, whichever one is not negative is the axis that it's going to cross. So let's look at this graphed in parametric mode. Now, we don't have a button for secant. So what do? 1 over cosine. Okay, secant is 1 over cosine. We do have a button for tangent. Okay, it graphs it kind of weird. Not really the way that we're used to it graphing it, but it does end up putting it in there. I'm going to go back standard zoom because that looks kind of all bunched up. It's hard to see. But I told you the other day when it graphs these, it actually puts the asymptotes in there for you. That's what the x in the middle is. But here is the actual curve of the hyperbola there on the left and on the right. It's centered at the origin. It crosses the x-axis. All right, so same thing. If you were approached with this problem, multiple choice, graph it. Okay, graph it, and if you can remember that a hyperbola, you subtract, you're halfway there. Hopefully you can eliminate some answer choices by looking at that. Okay, so let me just remind you, okay, we did some of these yesterday in example 1. It asked us to eliminate the parameter. Okay, that's another way of saying write it in rectangular form. This is parametric form when it's x of t and y of t. Rectangular form is when it just has x's and y's. So in example 1, it was really easy. We substituted. Okay, we solved one of them for t and substituted it into the other function. We did not do that with these because to solve one of these for t, we would end up using inverse trig, and it would just get complicated. It's better to use this method here using your Pythagorean identities. Okay, so this only applies when there's trig involved. If it's just regular x, y, and t, there's no trig, then solve one of them for t, plug it into the other one so that you only have x and y. Okay, does that kind of make sense?